Okay. Okay, welcome everyone. I'd like to get started. Please be seated so we can get started. So welcome to week 2 of this course. We will be discussing JavaScript today, but before we get there, I'd like to briefly reflect on assignment 1. So we had the deadline for assignment 1 an hour ago. Did you all manage to submit something? So according to statistics, I think most of you did. Were there any issues, problems with assignment 1 that I should know about? Who thinks that you did quite well for assignment 1 and you will pass with a good mark for assignment 1? So, who of you expect troubles with assignment 1? Can you briefly say what you expect in terms of what went wrong? Let's speak up, yeah.
We have a lot of trouble fitting the tables
Speak. The table in the mobile, okay, but that's a relatively minor issue, I think. Okay, other issues? Okay, so this is the general question, what is good structure in HTML, and should you put everything in divs or not? So if the TA really said you should put everything in divs, okay, friends, okay. So that would not be my advice, right? But it's definitely so. So I think the design book explains quite well what is good HTML structure. So I think if you follow these guidelines, they align like 99% with what I have been learning over the years myself. So I really like the guidelines of the design book here. Okay. Are there any issues with assignment 1? Okay, so for this week we will be discussing JavaScript. Assignment 2 will be all about JavaScript. The assignment will build on top of the assignment 1. Right? So you will use the HTML and the CSS that you made for assignment 1. You will reuse that and you will extend it with JavaScript functionality in assignment 2. And that means that whatever you wanted to do with HTML and CSS in assignment 1, but were not allowed to do, right? Feel free to do that now, because you will not be graded on the HTML, you will not be graded on the CSS. So if you have wishes on your phone shop, you think, that didn't fit the assignment, but this is your chance to do it. You will not be graded on it, you will not get extra points, but you also not get penalty points for it. It also means that if, so for example, if your table didn't work well in your mobile version, right? That doesn't matter. If your table doesn't work at all, then it's hard to manipulate that table in assignment 2 using JavaScript. So make sure that the minimum things that you need from the HTML in this assignment work, and if they don't, you talk with your TA during your lab sessions to make it work, right? So you don't need to have a perfect assignment 1 to make assignment 2, but if you have no table at all, it will be difficult. Okay, so I briefly put up the content table of the design book. Just to show you, we're almost there, right? So in the first week, we already covered the first 5 chapters of the design book. So for this week, we'll be concentrating on chapter 6, 7 and 8. For week 3, we will do the Node.js chapter 9, and the rest is optional. Right, so if you think design book is a lot of work, yes, it's a lot of work, but it's also, we're almost there. So I will, for the assignment 2, I assume that you will have read chapter 6, 7 and 8. So if you have not done so already, please make sure you do it before your first lab session tomorrow or Wednesday, because you really need these chapters to be able to make the assignment and to work effectively on the lab. Having said that, I think the design book is very clear, so I really urge you to do the design book yourself. I will not be using a lot of the design book here in this lecture. I want to do some of the slides I did last year before the design book was there, just to give you a different perspective on the same material. So one of the things I want to work towards is this example. So this is the stock exchange in Amsterdam. You see updates coming in, and what I really want you to gain from this week is that at the end of the week you think, oh, I understand how this table works, and actually I can do things like this myself. Right, so you will see that a lot of things that you do in the assignment look a lot like this example here. The only difference is that the table that you're working with will be a table with information about phones instead of the stock exchange, and it will not come from a live server, but it will come from the database that's running on your laptop. But apart from that, there will be a lot of similarities. So if you visit a page like this, and this is just an example, right? There are many pages like this on the web. This is just an HTML page like you have learned in assignment 1, right? So the table that you see here is just an ordinary HTML table with headings and rows and table cells like you have learned in assignment 1. The styling, it's all done using CSS, right? So the font types, the paddings, the margins, the colors that you see here, that's all just CSS. So everything is very similar to assignment 1. The only special thing, of course, here is the live updates. Right? So after the page is loaded, the initial HTML data is put in the table, but when that's done, there are these constant live updates. Right? So you see new numbers coming in, but you also see if the stock goes up, right? It will be marked shortly with a green background, so the CSS is changed. If the stock goes down, it will have a red background. If the overall average is higher than yesterday, it will be permanently red, but if it flips, it will also change. Right, so they change both their content and they change the CSS live. And if you think about, okay, how would I do that in HTML and CSS only? I hope that you come to the conclusion, I cannot do that by just using HTML and CSS. I need something else. And the something else, of course, is you need some program that runs while this page is being rendered on your browser. I need some program that runs in the browser and that takes care of these updates. So the program needs to do several things. It needs to get the information from some server, right? That could be the server from the newspaper, it could be the server from the stock exchange, it could be a server from a third party providing these services. But just looking at this page, you can't tell. So it needs to get the information, and then it needs to use the information to change the actual content on your browser that is being rendered, right? So the program has access to the rendered version of your HTML page in your browser and can change the content of the tables, but it can also change the CSS. Now, how to do that is an important goal of this week. How to do this in general and what technologies are involved to do so. This is one of the many examples of the use of JavaScript on today's web. I think it's fair to say that JavaScript has become increasingly important.
There are many web applications now that would be completely impossible without JavaScript. So it's really has become one of the essential key technologies on the web. But it has not always been this way, and because I think of the bit of the bumpy history that JavaScript had in the past, the image of the programming language that JavaScript is really, I think, what do you say that is diverse, right? It's there are very strong proponents of the language that thinks the language is cool, is nice, but there are also a lot of people that think the language is a kind of a toy language, badly designed, and should never have become as popular as it is now. I'm not going to give you my opinion on this or say that my opinion is the right one, right? But what I want you to understand is where this discussion comes from, and that you can take your own position in this debate with good arguments. So, if you look back at what we learned in the first week, right? So one of the things I really want you to understand is this difference between the web and internet in general, right? So the web is much younger than the internet. The web was built on top of the internet. The web would never be the success it is now if the internet was not already there when the web was invented. You have these key technologies, URLs, HTML, and HTTP, that were newly introduced by the invention of Tim Berners-Lee when he invented the web, but he built on top of standards like TCP/IP and the domain name system, DNS. We have this terminology, right? We have web clients, like browsers, that use HTTP methods to send requests to servers to get resources, pages that are identified by a URL. So to help communication between web browsers or clients and web servers on the other side is handled by this HTTP that we will come back up later in the course. There is a separation of concerns between HTML and CSS. HTML for the content of your document and for the structure markup, where the structure is basically a tree structure, and then how you show the content in this tree on the screen is defined by CSS styles. Now this emphasis on HTML content is a tree structure that we're going to reuse again in the JavaScript context, because we're going to use the data structure that the tree is to modify the tree while it's being viewed on the screen by users. So that's important. I will cover basically the first chapter, about the second chapter in the Zaya book, and then in the afternoon we will do the event programming part and the Ajax part that you will need for the assignment, and the jQuery library that you will also need for the assignment. And again, right, I don't want you to be able to write JavaScript programs by heart. I will not test that on the exam, but I will test on the exam that you can understand why you need JavaScript in the first place. So remarks in the beginning, right, that the table you can do in HTML with the live updates, you need something more like JavaScript. These are things you need to understand. I want you to be able to learn from examples you find on the web. Right? So, like I said for assignment 1, don't be afraid to imitate cool things that you find on the web. Feel free to copy paste, as long as you document where you copy paste from and that you understand what you copy and paste. That's fine in this course. And again, I think that's even stronger than in assignment 1. You need to be able to make mistakes, right, and to find them. It's not bad to make mistakes. I think it's even good. Sometimes I make mistakes intentionally just to see what happens, and I learned a lot from that. So please make mistakes. Don't be afraid of it, but also learn how to fix them and how to fix them efficiently. And especially for this assignment, but also for assignment 3, right? If you at the end of the week don't submit because you have spent 2 days, 3 days on a single bug that you cannot find, then you're not spending your time efficiently, right? If you cannot find it after half an hour, stop, do something else, talk to your lab partner. If he or she cannot find it, talk to your TA. If that doesn't work and you're at home, send a mail to the mailing list. But do something else than just staring at the problem and not getting anywhere. Right? So there's no bug in assignment 2 or assignment 3 that is worth more than an hour of your time. Right? And if you spend more than an hour, then I would try to do something else. And either you give up and you just document in the assignment what you have done to fix it and why you failed, right? Because that's also informative, and that can also get you points if people see that you're almost there, but fail to see one tiny issue, then you will still get many of the points. But don't spend too much time on debugging. Having said that, right, of course it is very important that you do find your own mistakes, and learning to do so efficiently is really, I think, a technique that you can also start learning here in this course. So a bit of historic trends and backgrounds. The thing that really made the web popular in the beginning, right? So when Tim Berners-Lee made this invention, was this notion that you have documents with content in the beginning, mostly academic papers, right? But later more other diverse content that was available 24/7 from everywhere in the world to everyone in the world, right? So that we find it now completely normal that we don't only access a Dutch newspaper, like I showed you in the beginning, but also maybe a tiny newspaper from the other side of the world. It is now completely normal, but was really innovative at the time that the web was invented. So these notions of documents being available so easily from any context was really innovative then, and made the web very popular. So the other thing that made the web popular were these hyperlinks between documents, right? So that if one document referred to another document, that by just one click you could also access the second document. And that you can do that with only installing one program on your computer, the web browser. So these things together were really characteristic for this first wave, which is, with hindsight, often referred to as Web 1.0. Right? And then the second innovative wave in the web began with the rising popularity of social media. And then suddenly it was not about documents anymore, but it was much more about people. And not only the links between documents were important, but also the friendship links or other type of links between people became important. And where the first innovative wave of the web was really characterized by traditional large organizations putting in the content, the second wave of web was really also about user-contributed content. And so the fact that, for example, on Wikipedia, right, it's not one large organization that puts in all the content, but that individual users can do so, made a big difference. And with this social media popularity rise, also the web as a platform for other type of applications than just viewing documents became really important. And it's this platform that supports other functionality than just viewing documents, also needed other technical support than just HTML and CSS. And so this is the Web 2.0 it was also the area where JavaScript really became a crucial technology. So JavaScript, like the other technologies that we had, was playing a part in browser wars. Right? So the different vendors of browsers trying to get more market share also used JavaScript to do so. So JavaScript was already introduced in 1995, so that's really a long time back. In the earliest, one of the earliest Netscape browsers, in the browser where Microsoft soon followed with something else. They didn't call it JavaScript, they called it JScript. And by the way, the JavaScript language introduced by Netscape also had nothing to do with Java. And the fact that they called it JavaScript was also just for marketing reasons, because then, at that time, the web language, programming language was Java. So this was also more a marketing issue than a content issue. Then the European standardization organization, ECMA, developed a standard that became widely adopted, so it was more successful, I think, than most people thought. And this language became known as ECMAScript, so the standardized version. And I think that in practice that is still what people use today, right? But nobody calls it ECMAScript, everybody calls it JavaScript. So from a standardization point of view, this is I think quite a success. From a branding, if ECMA wants the name to be known, I think it's not a big success, but I think for us it doesn't really matter. So there are of course different versions for the assignment too. It doesn't really matter that much to which version you stick, as long as it works in your browser and you test this with another browser, like in assignment 1. So if you look at JavaScript purely as a programming language, I think there are some things you can say about it. So who of you has had time to look at this first chapter in the Zai book about JavaScript? Right? Did anything stick out? Do you think that surprises me? Never knew that.
It's very similar to C++.
Very similar to C++. I see people nodding, right? So when it comes to a programming language, I think I had to say the first time I saw it, I thought, what is special? Couldn't you just have used C++ or Python or whatever? It's very similar to other languages, right? So in terms of how the syntax looks, it has the curly brackets that most of you will know from C++. But also, if you have done the programming course in Python, you will see very similar things. The if-then statements look the same, the while loops, the for loops, exception handling. So everything that you know or don't know from Python or C++ or Java or whatever will be familiar also in JavaScript. So as a computer science innovation in that sense, right? I can understand that it doesn't have a big reputation. It was not really innovative in that. And if you look at the early examples of how JavaScript was used, I'm going to show you just to get an idea that some things. So this is the infamous image flip. So if you ever have seen this, this is an image. If I hover over it changes a bit. Right? This was way cool in '95. Right? This was a trend that many developers imitated from each other because it was the talk of the town. And it's just completely hard. Yeah, for me it's very hard to imagine that this was the case when it was. And of course, if this is the main use of your language, right, that doesn't help in your reputation. So another already more useful thing. This is from the W Schools live try it example. This is about making drop-downs, right? So you have these drop-down menus on the top of this the code. This is the web page itself. You have these drop-down menus. Sorry, where you can navigate through your website and the drop-down menus look much more like you have with normal GUI applications on your desktop, like a Windows or Mac application with these drop-downs. So before these drop-downs were available on the web, people didn't have them. So when they were introduced, people really liked them. But it also meant that you could not navigate the website if you didn't have JavaScript enabled on your browser. So in the early days, when some browsers did have JavaScript and some didn't, this was also nice for the people that did have JavaScript, but not so very nice for the people that didn't. So that also didn't really help getting JavaScript a better reputation. And nowadays you can actually do this without JavaScript, right? So you can do the same functionality in CSS and HTML. So I earlier mentioned this notion of this form validation, right? So you fill in a form and then you submit, and then something goes wrong and you need to fill in the entire form again. So this was also something where JavaScript was introduced, where some program that actually checked if I press the send button, there's some piece of JavaScript that starts running and checks if I actually did fill out the form correctly, and if not, it gives me a warning and gives me a chance to fix this before it was all sent to the server. Right? So in this case, the submit button never submitted something to the server because the JavaScript blocked it beforehand. So this actually became useful. Also here, right? If you have played with the HTML required attributes, your assignment 1, you can also see that a lot of these things you can also do without JavaScript. And then we come to this more platform-oriented use of JavaScript, and that really changed the image of JavaScript as a language. Right? So that was wrong. So this is Google Maps, right? So you all will know it. So anyone, how do you do this on the web? So how is Google Maps work from a web technology perspective? What do we see here? Is this HTML or not that we're looking at? I see people nodding now. Is this HTML or not? Is this an HTML page? This is an HTML page, right? So this is a div. The images here are just HTML images tiled together. This is good old HTML that you're looking at. If you look at Google Docs, it's all HTML with CSS. So all these web applications that you don't perceive as being a document, right? It's still HTML. What's of course special about it is if you scroll, then there's constantly new images added here, and there are images disappearing there, and it looks like one big map. But if you do it too fast, right, you will notice that if you have a slow internet connection, that it needs some time to get the new images from the server and to get them on the page. But this is just HTML, but with JavaScript functionality added. So the usefulness and the ubiquitous of these kinds of platforms, this really changed the image of JavaScript as a language. And currently, if you look at usage statistics of programming languages, JavaScript is really one of the most used languages in the world. Right? So it completely changed from this stupid image flip to the key language of building these platforms. And what I said for Google Maps, right, is true for many of these platforms. So one final thing I want you to show is this autocomplete functionality. Right, so you probably know this from Google Search, right? That if you type something, that the program gives you suggestions of what you might intend based on the few characters that you have typed. Right, so in this case, I've only typed one character. This is done using jQuery, so this is the library you also can use for assignment 2. But if you do this in the Google search bar, right? So what happens here? If I type C, well here it goes also to my a bit of my history, but also so what do we see here? These suggestions, what are they based on? So I type CSS, right? I type 3 characters, and I get this as a suggestion from Google. Where is this based on? Where does my browser get this information from? Anyone?
I just don't know how to pronounce it. Cache?
Sorry?
I don't know how to pronounce it, but is it cache?
Is it cache? Yeah, so that would be the history of the things I've showed before. Right, so when I only type C, the cauliflower result of Jamie Offer is what I had for the weekend. So that's definitely from my search history, that it comes from the cache. So that's very good. But that was because so the CSS validator is also from my cache, because there were questions about CSS validator for assignment 1. So very good. But all the things that are below, I think, the top 3 are things I've never searched for before. So these are definitely not from my cache. But they are from another cache. They are from Google's cache. So these are other queries from other people that Google counted as the top queries starting with CSS. So this is really asking Google, okay, what are your top queries for the string starting with CSS, and then mixed with my results. And also this is just HTML, right? This is just HTML div with bold text. This is all just plain HTML. Okay. Let's go back to the presentation. So one of the things this resulted in is this style of a website that doesn't feel like you're surfing or browsing from one document to another, but it feels like it's an application like a normal desktop application that you stick on one page. You have menu items. You have all kinds of functionality that helps you to accomplish other tasks than during documents. And these single page interfaces or single page websites are now almost standard. So there are many websites where you can do all kinds of things without ever leaving the home page that you entered in the beginning. So if you've done the document, the design book, right, you see that in many ways the syntax is familiar. So comments with / and then the rest of the line is a comment, or you can use / star as in C++ for comments. You have statements ending with a semicolon. For people doing C++ or Java, that will be very familiar, but also if you have done Python, this will not be completely unfamiliar. Blocks between curly brackets. Okay, in Python you would use indentation, but the notion of a block, right, should be familiar. You have while loops, if statements, etc. So I think everything is very familiar. The object notation using the dot, right? So you have some object name dot property, that should be familiar to many people. I want to focus a bit on the differences. So JavaScript is an interpreted language, which means that in the normal situation it's not compiled, but interpreted. So more like Python than like C++. So if you edit, you can immediately run your new code after your edit is complete. You don't need to compile first. But what's really different is the typical environment for if you do client-side JavaScript programming that we will do in assignment 2, is the environment that hosts this interpreter, that runs this interpreter. Right, that makes it really different from what you have done in the programming course, for example. the fact that you will run this in your web browser makes this whole situation different. And so, how do you typically start your JavaScript code in the client's environment is that you load the HTML page that refers to the code, right? And the idea is that your JavaScript does something on your HTML page, and if it doesn't work, you need to find the problem, fix it, and then reload the HTML instead of reloading directly the JavaScript. So we will come back to that quite a number of times. And also, if you think of this from maybe from a security perspective or the separation of concerns, it's actually quite odd that you load, in general, you load an HTML page from a site that you might not know or not trust, right? And that while your browser displays the HTML page, it suddenly starts also to load a piece of code and run that on your machine while there's full access to the browser window that you're currently viewing, and everything happens on your machine without you knowing, without you explicitly installing an app or installing a program. And so the whole situation in which JavaScript is typically used is really different from other applications. And the fact that you can use JavaScript like in the HTML table that we saw for the stock exchange ticker, right? It can add or change or modify or delete anything on the page. Makes it really powerful, but it also allows potentially for abuse. So also keep that in mind. Always two sides. But the more explicitity, the more functionality, also the more dangerous it is for abuse. Are there questions about this? Because I think that this is good to realize, right? It's on the one hand side, it's just another programming language that doesn't seem to be too much different from Python or C++. But on the other hand, the fact that every browser has a JavaScript interpreter and just starts to run these programs while it's showing your HTML pages makes it really different from these languages, or the typical use of these languages. So one consequence of this, you run it in your web browser, is the fact that there's no normal print statement, right? We'll see some things that look like a print statement. So typically, if you look at the hello world of JavaScript, you will see something like this: a window.alert hello world. And what will this do? If you run this piece of JavaScript in your HTML page, anyone? So this will give you an annoying pop-up window, right? On top of your browser window that gives you this type of text. And so it's because there's no terminal where you can send your print statements to. So the exception is the console that we saw already in assignment 1. You can also log things to the console for debug reasons. So if you want to print some debug messages, you can do using console, and then your users will typically not see it only if they open the console. So do you get some feeling of because it's in the browser, it's different than other programming languages, right? And this is just one of these examples. And like I said, if you want to run a piece of JavaScript, right? So if you want to run this example, what you typically do is you make some HTML page where you want to run this piece of code, and then in the head you refer to the file either on your own website or with a URL on a different website to run to instruct the browser that if you view this page, like if you render this page, you should also load and execute this JavaScript file. And so, suppose you make an error in this, you forget to close the quotes of the string, right? So what you do is find the error, fix it, save it in the JavaScript file, right? And then reload the HTML file in your browser. That's the typical sequence. And again, if you make an error, right, you will probably see that it doesn't work. But if your web developer tools console window is not open, you will probably not see any error messages. So for assignment 2, my advice will be, before you begin, you open your web developer tools, you open your console, you make a minimum example like this, and if it works, great. But just make a mistake on accident and run it again and see if you can see the error messages. Right? Because if not, when you're working in the dark, it will be hard to do the assignment. Okay, we'll come back to that later. I'll skip this. I will give you one example of a language feature that's really different from what you will be known when you use with C++ or Python. Is that you have objects like in Python and C++, but you don't have classes in JavaScript, and that might require you some getting used to. I think when you get used to it, it's actually it also has its advantages. Having objects with no classes make these objects really flexible, right? Because the objects have no rules superimposed by the class that they need to convert to. And basically, what an object is just a set of properties, right? Where every property is a key value pair, and every time you assign a value to a property that you have not used before, you basically invent a new property in your object. So if I have an empty object O, and I say O.property is true, and I suddenly have an object with a property, a Boolean property with the value true. And if I then, after that, make the similar assignment with true in quotes, right, I don't get an error that I have a Boolean property to which I assign a string. I just change the property into a string value with the string value true. Now, if you like this or not, right, that's a different question. And this is how it is. So if you are of the class, okay, this first statement should give an error because I assign a value to a non-existing property, I can understand. That's not how it is in JavaScript. If you're of the school that say, okay, the second assignment should give you at least a warning or an error message that you are mixing up different types, I can understand. It's not how it is. So this is all perfectly valid from the JavaScript language perspective. If this is smart programming, it's something else, right? But it's allowed. Okay, so for the sake of time, what do we do? Just let me finish this. So there are no classes. Objects can be created dynamically. You can add things like I've shown before. You can also delete them later, right? So if you have opened one testing, this is test. There's a string property with this value. If you then later decide that you don't use it anymore, you can just delete it. If you then, of course, later on in your program rely on the one testing existing, you will get an error because it doesn't exist anymore. But it is very flexible. And you can write functions, special functions that help you create objects. So the first assignment is that the wrong way to do this. So you make a new empty object. You assign property 1, you assign property 2. But what people use in real life is this syntax, the shortcut syntax, where you just list all the property value pairs between curly brackets with key, column value, comma, key, column value, comma, key, column value. Right, so this is how you define an object as a set of properties. And if you need to do that a lot, you can also create functions for that. So if I make a function my object, then I can use this special this variable that points to the object itself. Right? The moment I use this, then the function already becomes a created function, a constructed function. And then if I then make an assignment, variable O3 is a new my object with some parameter. It will be assigned a P1 value with this value and a P2 value in this case with the parameter. Is that clear? So there are no classes, but the objects that result from it are very similar to the objects that you would get from a class, only they are much more flexible. You can change them at runtime at any time you want. Okay, I want to break here. We'll get back at 12, and I will show you how you use JavaScript to interact with HTML and CSS using the document object model.